Hi, my name is Tina, and this is my project on the introduction to radians. Usually when it comes to the idea of measuring an angle, we all use degrees. For instance, when having an angle similar to these, we may call this one a 30-degree angle, this a 90-degree angle, this a 180-degree angle, and this a full 360-degree angle. The idea of using degree has gone back to hundreds of years ago, bringing many theories of why it came to be. Although we are used to measuring angles using degrees, it is not the only way to measure an angle. Instead, many have been taught the idea of using radians, which is more mathematically reasonable than using degrees. To get you into the topic of radians, let's go ahead and draw a circle with the center right over here and a radius going from the center to any point on the circle. The length of the radius, let's say, is length r. Now let's construct an angle theta. The angle theta is used to name an angle that is unknown, and let's just say that for some reason this angle theta is the exact measure that allows the arc that subtends theta equal to the radius. The word subtends shows that the arc along the circle that intersects two points that make up an angle, or in this case theta. So what would you do if you wanted to find the measure of theta using radians? If we view radian as another way of saying radii, we would call theta 1 radian because we know that the arc is subtended by an arc of 1 radius. This is how radian is defined because when having a circle with an angle of 1 radian, the arc that we see subtending it over here has the exact value of 1 radius. Knowing this will come in handy when looking at different types of circles. Here we know that the arc that subtends this angle is one whole rotation of the circle, which makes it 360 degrees when using degrees. But what would it be when using radians? The circumference of this circle is 2 pi r because the radius is r. The length of the arc is how many radiuses there is, and we already know that there is 2 pi radiuses. So this angle I will call x is 2 pi radians, and it is subtended by an arc of 2 pi radiuses. Now that we have an understanding of both measurements of degrees and radius, let's learn how to convert radians to degrees and degrees to radians. So first we have 2 pi radians, which we already know have the degree of 360 degrees because it describes the full rotation of one circle. If we divide both sides by 2 pi, we get 1 radians equals to 180 over pi degrees, which can be used to convert radians to degrees. On the other hand, let's try to find the radian of 1 degree. We first start by dividing 180 on both sides, which gets us to pi over 180 radians equals to 1 degree. With this, we can convert degrees to radians. Now, let's move on to example problems. Number 1. Here we see that the angle being represented on this circle is 90 degrees with radius 1. What would this be if converted to radians? As we learned before, 1 degree equals pi over 180 radians. So in order to convert 90 degrees to radians, we multiply 90 over 1 with pi over 180, which gets us to pi over 2. So the angle of 90 degrees on this circle is also equal to pi over 2 radians when converted from degrees to radians. Example problem number 2. The angle we see in this circle is the radian of 3 pi over 2 radians with radius 1. What would this angle be if converted to degrees? We already know that 1 radian equals 180 over pi degrees. So in order to convert this into a degree, we multiply 3 pi over 2 with 180 over pi, which results with 270 degrees. The angle of 3 pi over 2 radians on this circle can be represented as 270 degrees when converted from radians to degrees.